Right. So, third learning outcome, be able to design a database system. Design a relational database to meet the specified design brief. Explain how design documents meet the design brief. Evaluate database design following feedback. So, relational database design will be discussed by the design fundamentals. Then logical versus physical design will be discussed. Database documentation, stakeholders of the database documentation types. Then database evaluation performance, evaluation benchmarks, verification and validation will be discussed. So we start with the database design. So a well-designed database is a prerequisite for a fast data retrieval and data updates. Before you build the data tables and other objects that will make your system, it is important to take a time to design it. A good design is a key stone to create a system that does what you want it effectively, accurately, and efficiently. So basic steps in designing you should consider to determine the purpose of your system, why you are designing, determine tables that you will need in the system, determine the fields you need in the tables, what fields it will need, what fields with unique values, determine relationship between tables, define the database to add the data and create other objects that you should really be able to know in advance. Entity relationship diagrams, you should be able to know that what entity is related with another entity, which entity is related with which entity, and how they will be related. For example, sales representative, product, warehouse, customer, order, they are basically related with each other, and they are to be defined with entity relationship diagrams. And within the entity relationship diagrams, you will need to define the relationships in between them. For example, once we discussed the relationships earlier, like one-to-one, one-to-many, many-to-many, and those relationships should have been defined using the entity relationship diagrams. So certain symbols could be used for the entity relationship diagrams, like this process, this oval, this square, the rectangle, this and the triangle. This is called the decision, and there are all of these symbols, and the relationships could be defined one-to-one, one-to-many, and those concepts we discussed earlier. So everything should have been represented through the entity relationship diagrams that you will need to create for your database design. Then you should define the data flow diagrams, that how the data will flow from your database. So it is defined using the data flow diagram. For example, user puts the order which is processed through the process order, and then an entity, this particular process gives further information to the invoices. Certain orders are generated. User is supposed to start the collect payment action. Fulfillment is carried out. Shipment is done. So kind of data flow diagram is necessary to define in advance in order to provide the clarity of the database design. Otherwise, without the data flow diagram and entity relationship diagrams, you cannot design a database. So certain data flow diagram symbols are external entity, process, data store, data flow. So entity could be represented with the square, process is 0, data store is represented with a cutoff, and this rectangle data flow is represented through arrow. Now database development review. A design review are the important aspect of the system development life cycle. So you should consider the review of certain things so that you could develop a proper database system. You should review the conceptual design, you should review the logical review design, you should review the physical design, organizational review, SQL review, pre-implementation review, post-implementation review. So the conceptual review is the first base, should be the conceptual design review. Purpose of this review is to validate the application concept, whether you have the valid application concept or not. If there is a case, this involves the presentation of the statement of purpose as well as general overview of the desired functionality that will be provided by the application. So conceptual view, you should be very much clear. Logical view, all data elements, descriptions and relationships should occur during the logical design review. So at the superficial level, you should know that which elements would be used and what relationship would be used among them. Physical design review, in this component which most DB2 developer associate with the design review, physically, that how physically you will be storing into the database and which database actually you will be using, like a DB2, and how you will be creating the tables, how you will be storing, how you will be giving the space allocation to them. Organization design review, smaller in scope but no less critical, is organization design review. This review addresses the enterprise-wide concerns of the organization with respect to the application being reviewed. So what are the concerns of the organization for which you want to design? SQL design review. The SQL design review must occur for each SQL statement prior to production turnover. So SQL is basically a structured query language. You really should be able to review that how you will be retrieving the data from the database, and whether will you be able to retrieve the data using the SQL or not, so that you should be very much confident that your retrieval query is sufficient to retrieve the data. Pre-implementation design review, the 6 phases are the pre-implementation design review. Simply consists of overall the review of the system, which we discussed earlier, and the post, like these, we discussed physical and the logical, physical, organization, SQL. These are the pre-implementation design review. The post-implementation design reviews are the final phase in the post-implementation. This is necessary in order to determine if the application is meeting its objectives. These objectives include both performance objectives and functionality objectives. If any objective is not being met, a plan for addressing the deficiency must be proposed and acted upon. So post-implementation gives you a testing, pre-implementation gave you a kind of the 5 steps. So it was about the first point of the learning outcome, which was the database design review, fundamentals, and logical versus physical reviews. We come to the second one. Database documentation or database design documentation. Documenting a database during its development is best practice to ensure that the organizational schema, data objects, and other related information are captured for future reference. This documentation often takes many forms, including data dictionary, database administrator guides, database architecture documentation, and database functional specification. Normally, use the term data dictionary to refer to the database documentation. The database documentation serves multiple audiences, including database architects, developers, database administrators, production support staff, quality assurance staff. The information included in the data dictionary is hidden from normal users to prevent any corruption of its contents, while the data dictionary in a database serves an administrative and management function. It does not include any actual database data, though a relational database management system requires a data dictionary to access data from the database. So if you have a data dictionary, then according to the data dictionary, the data is retrieved. Some more slides about the data dictionary are given at the end of the slide, and I will complete these slides first. Typical elements to include in your database documentation: you should consider capturing the following information in your database documentation. For example, data element numbers, how many data elements you will be using, the names of the data elements, the short description of data elements, security classification for data elements, listing of related data elements, field names upon. So whatever basically the data you will be using is basically the metadata, means the data about the data. If you say that you have a customer table, then the customer table itself is defined by a certain metadata, that okay, the customer table will have 6 columns. Each column will have the particular size, particular integrity constraints applied. So that kind of database is basically the data about the element. So this is a kind of database documentation. So typical elements include the database documentation, code format, the default values, the element coding, the references to other documents, database table references, sources of element, valid dates, history references, external references, data element version. So these are highly technical terms, but you should be able to understand that these are the key concepts, and when you will really look at the particular database documentation, then you will find some specific implemented ranges and data there in particular database. The database table information documentation, you will also need the database table documentation. So if it is a table, as I already explained, that table should have a table name, database or table name owner, data element columns, names and details, key order for all elements, database index information, technical table organization, duplicate row information, are the duplicate rows allowed or not, data element list, table security classification. So these are kind of higher abstraction names. Previously those were the more detailed technical names of the fields that you need to define about a table. Next is the database architecture, focuses on design, development, implementation and maintenance of computer programs that store and organize information for businesses, agencies and institutions. A database architect develops and implements software to meet the needs of users. So architecture is basically the design, development and implementation and maintenance. So all together, everything related with the database is the database architecture. And here is the data dictionary. Data dictionary, for example, the users are student, lecturer, course, subject, and the table space name is users. This one is user, course is not given the name, subject users, the cluster names are empty, status is valid, etc free. These are highly technical terms. So that is the dictionary about the users table. Select asterisk from users table. It means how the users tables is stored, in which names, which particular constants are applied. So this is a kind of data dictionary, a dictionary of the database structure. So Advantages of the data dictionary: it gives the well-structured and clear information about the database. One can analyze the requirement, any redundancy like duplicate columns, tables, etc. It's very helpful for administrator or any new database administrator to understand the database. Data dictionary helps user by providing all details in it. Disadvantages: it should be well designed in advance to take the advantages of it. The cost of data dictionary will be a bit high as it includes its initial build and hardware changes as well as the cost of maintenance only for technical usage. So obviously it is helpful, but when you will really wanted to create the data dictionary, you should have expertise, you should have time, and you should have the reason to create it, otherwise it is useless. So the second point is also discussed. Now the third point is about performance, database evaluation, performance evaluation, benchmarks, validation and verification. Once you have a database, you should be able to test the database. Database testing includes performance data validity, data integrity testing, performance check related to database, and testing of the procedures, triggers, functions in the database. Consider an application that captures the day-to-day transactions details for users and stores the details in the database. From database testing point of view, the following check plans should be performed. The transactional information from the application should be stored in the database and it should provide the correct information to the user. For example, if the user is not getting the correct and updated information from the database, it means the database is not working. Information should not be lost when it is loaded into the database. It shouldn't be the case that, for example, you stored certain elements into the database and you stored certain data into the database, then some of the records were missed or lost or the corrupted and you got a loss. Only completed transactions should be stored and incomplete operation should be aborted by the application. Like I discussed earlier, the commit and rollback, like a transaction processing systems, the transaction should either be completed or incomplete. It shouldn't be the case in between. Access authorization to database should be maintained. No unapproved or unauthorized access to user information should be provided. Structural database testing should be done. Functional testing should be done. Non-functional testing should be done. Structurally, it deals with the tables and column testing, schema testing, stored procedures, and view testings, checking triggers. Functional, it involves the checking functionality of the database from user point of view. When you talk about the structure, it means you are checking each and everything one by one. When you talk about the functional, it means a user is testing. Most common type of functional testing is white box testing and black box testing. Non-functional testing involves the load testing, risk testing, database testing, stress testing. Basically, white box testing it means you look at every internal component one by one, and like you are testing the internal units of a database. When you are doing the black box testing, it means you are testing a system as a whole. You are not going to look at into the database components with open eyes, or for example with a white box, cleared or visible box, but black box overall. Okay, whether the system is doing good or not, that's a black box, and the white box is testing each and every small component. While non-functional testing is basically that's the testing which you are not doing by yourself, but it is done automatically. For example, if you are loading the database, if it loads, okay, it means you are doing non-functionally, and that's fine. A risk testing in the database, if it is not giving you any problem, if it is not passing the stress testing. Stress testing is, for example, if you are using the database for too much data, then whether it is capable to take the stress of the data or not, whether it is fulfilling the requirements, the minimum requirements or not. So overall, the performance testing of the database is non-functional testing. Then structural database testing involves the verifying those components of database which are non-exposed to the end user. So structural database testing is basically you can say that white box testing. You are looking at into each and every small component. Schema mapping testing. Schema, it involves validating the objects of the front-end application with database mapping. So, for example, in the Microsoft SQL Server, a tester can write simple queries to check and validate schemas in the database. If the tester wants to make changes to table structure, he or she should ensure that all the stored procedures have that tables are compatible with this change. For example, structure testing, functional testing, non-functional testing. So overall, whenever you are required to test any individual component from structure to function, function to non-function, everywhere you map the objects, you validate the objects, and when you do an overall testing, it becomes a mapping of the testing, whether you are providing or sending particular data from one table or not to another table successfully or not. So overall, schema testing, map testing is done, which is interrelated with different structures. Structural testing, functional testing, if all goes through well, then your map testing is done. Structural database testing continue. Stored procedure and views testing. Basically, you create some procedures, methods inside the databases. For example, if I say a count function can give you the total number of records into a table. So it can be a predefined function or user-defined function. So you need to test it. Trigger testing. Triggers basically you create in a database in order to create particular actions to be taken by the database. Tables and columns testings. Validating data tables into the fields. For example, if you have applied certain constants into the database, like unique constants, the primary key constants, referential key constants, not null constants, then basically you are doing the tables and columns testings, that whether they are working fine, the constants are working fine or not. Database server check. The database server checks involves the verifying the database server can handle the expected number of transactions as per the business requirement. So, for example, if the server is supposed to do the 100 transactions at one time, then probably you could check your database server that whether it can really do 100 transactions at one time or not. Probably it could fail at 60 transactions and probably may not fail, and it could be okay with the 120 transactions. So database server is to be checked. Functional testing we discussed earlier. The internal components, the black box testing will be the overall system checking. White box testing will be the individual components in detail. Non-functional testing is basically the performance. It could be the load testing. It could be the stress testing, that how much the stress could be given to the database, and the components of the database, that there could be the database components includes one or more tables of the data, the query languages, retrieval specific data elements, forms for entering and displaying the data. Additional components could be reporting tools, customized page views. Relational databases have such schemas that define the relationship between the tables and may include components that automate the routine tasks. The components overall could be the tables, queries, forms of a database, reports, pages, macros, modules. They really define the components. Extreme data, when choosing what data to use to test a system, you need to think about why we are testing the system, to see if it works, to check it if it doesn't work or breaks out. So normal data values are normal. This data that would normally be entered into the system should accept it, process it, and we can check it. Extreme values are the limit of the data. Extreme values are still normal data, but however the values are chosen to be at the absolute limit of the normal range. When I said, for example, a database could hold the 100 transactions at a time, then you definitely try to execute 100 transactions. That would be the extreme data value, and probably you could try with the 120. Then you will be able to do the extreme data. Then error handling, that how the database is able to error handling, what is the purpose of error handling, how the error should be handled in case of any inappropriate data is inserted into the tables, or any misconnectivity or any connectivity errors could be occurred. So the database should have some capability to handle those errors. So I hope that superficially you should have been able to catch the idea of these topics whichever I have discussed today, and as you will be reading again and again, then you will be able to more detail and with the more knowledge. So I hope you were listening to me. Can you get back to me, Khalid?
Yes, sir, I'm listening.
Okay. And Yusuf, I think he has a problem of the microphone, but I think he's definitely listening. And Yusuf, can you text me that everything was okay? And obviously I will upload this session, and if you have any question now, then you can ask now. Otherwise I will upload this session. You can read it, and as well as you can listen to the recording, and you can send me questions after the session via email. And I would advise you to go through the assignment briefs as soon as possible, as soon as the unit is completed, so that you should not forget the concepts which have been discussed into these sessions. So is everything okay now? Should we close the session now?
Yes, sir, you can.
Okay, that's fine. So see you next week for the level 4, and